So viewers, we looked at analytical method as one of the methods of approximating roots of equations. Now I want to look at graphical method. Graphical method. Now, when we talk of graphical method, the method of approximating a root of an equation or of equations, here we shall be able to draw a graph on a graph paper. We ensure that the axes are properly labeled. So these are the features of a good graph. Axes must be properly labeled. So when you draw your graph, you ensure that before you do anything, the x-axis is labeled, the y-axis is also labeled. Then the scale to use must be uniform depending on the given question. So if you start from 0 and are using a graph paper of such a calibration, if you begin from 1, then 1.2, then you can see between 0 and 1, then 1 to 1.2, that scale may not be uniform. But I can say start from 0, then 1, then 2, then 3, then 4. Or if I say 0, then I say 2, then 4, then 6, then 8. So you can see the gaps must be the same. If I start from 0, then 0.1, then should be 0.2, then 0.3, and so on, to ensure that the scale is uniform. The curve drawn, assume this is the curve drawn, must be labeled y equal to fx1, fx, and the line, if it is drawn, then you say this line y equal to x something, and where the line and the curve meet, draw a dotted line reaching the x-axis and estimate your first approximation to one decimal place depending on the question. And the graph paper must be used. The curve and the line must be labeled and the curve drawn with free hand. Draw a curve with a free hand, then a line with a straight ruler or straight edge. We can have one graph or two graphs depending on the given question, and at least 3 points within the given range for a curve, then at least 2 points within the given range for a line are expected to be used when you are drawing a table of outcomes. So those are the features of a graph, that the graph axis must be labeled. The scale used should be uniform and the initial values clearly indicated. And all what we have mentioned must be done on a graph paper. We can have a question like, show graphically that there is one positive root of the equation x cubed plus 2x minus 2 equal to 0. Similarly, you draw a table and you shall have fx equal to x cubed plus 2x minus 2 as our function, and we shall have a table x then f of x. Now the question, they have not given us the range, or they can say show that the equation has a root between 2 and 3 graphically, but this one is open. Therefore it is our task to get the range, and as we said, you can use plus or minus magnitude of k then plus 1, where k is the coefficient, the biggest coefficient of the terms. So here we have got 2, so we can start from plus or minus 3 because it will be 2 plus 1. which would be 3. Therefore, we can draw a table of values of x ranging from -3. But they have told us that we need to show graphically that there is only one positive root, meaning that we don't expect values of x which are negatives, because clearly they have said a positive root of the equation. And we can start from 0, then 1, then 2, then 3. These will be our values of x in the table, since the question says positive root. And when you put 0, it will give f of x as -2. When you put 1, that is 1. When you put 2, it gives 10. When you put 3, it gives 31. And you said this one, since it is a curve, we expect more than 3 points or more. You get your graph paper, and we shall be able to say that we shall have to draw the axis. The line should cross the initial value, if it is 0, the x-axis, the y-axis clearly labeled, and fx is from -2, so you can use -1, -2. Then since you have got bigger values 10, we can use a scale of 2, -2, -4, 2, 4, 6, 8, 10, and so on. Then we have 1, 2, 3 on the x-axis. Then you plot. You plot either using a sharp dot or a small x, but don't. This is not acceptable. Or all these are not acceptable. We accept a dot, sharp one, or a good x. So these are not acceptable. These are not acceptable. We expect either dot or x when you are plotting. And clearly 0, -2 can be indicated like that. 1, 1, somehow around there. 2, 10, around there. 3, 31 will be up there. Since it is a curve, then join the points using a free hand, and you label or name the curve as x cubed plus 2x minus 2. So you can see all the features of a good graph must be clearly followed, axis labeled, plotting a curve freehand, name it, then where it crosses x-axis, you mark that point and you put your x0 as your first approximation. And this first approximation is between 0 and 1. On a graph paper, it will be clearly red, and this can be 0.2 or any other value between 0 and 1, depending on what you read clearly on the graph paper. So that is how we draw a graph. If it was a line and a curve, then you draw a line with a ruler, but the curve must be drawn using a free hand. So those are the features of a good graph. Remember, we can have a question like this number 2, where they say use a graphical method to show that the equation has only one real root. Now we can split this equation, but it is open. We can draw one graph or we split it. So similarly, we can say let f of x be equal to y, which is equal to e power x plus x minus 4, and we draw a table again of x and f of x. Then x, you can see that this is a mixed function. We have exponential and linear, so we don't expect you to use the similar approach of k plus or minus 1, because this is an exponential function. So clearly we can start from negative, to begin with negative 1, then 0, then 1, then 2. Since we said that roots of equations in most cases they are around 0, so we can choose our 3 or more points to get a clear graph. Therefore, if you put negative 1 in your calculator, negative 1 shall have negative 4.6. If you put 0, you get negative 3. If you put 1, you get negative 0.3. If you put 2, you get 5.4. And you will see clearly that there is a positive and negative values of f of x, and we shall be able to get a clear graph. Likewise, viewers, when you are to draw the graph of a given question, like this one here, a scale, you will see that we have both negative and positives. On your graph paper, assume this is our graph, we shall have x and y labeled, and therefore on the x-axis we can use a scale 1, 2, 3, and so on, negative 1, negative 2, ensure the gaps are the same. On the y-axis we have decimals, so we can use 0.5, then 1, 1.5, then 2, 2.5, then 3, 3.5, 4, 4.5, 5, 5.5, 6, and so on. 0.5, negative 1, negative 1.5, negative 2, negative 2.5, negative 3, like that. So plot, and we expect you to give your values in the table to one decimal place for easy plotting, like how we have seen values of f of x have been given to one decimal place. Now, plotting the graph shall have 0, negative 3. Those are points to plot. Should be the first point here. Then negative 1, negative 4.6, negative 1, negative 4.6. This is negative 4. This is negative 5, and so on. And therefore, we shall be able to say that negative 1, negative 4.6 around here. Then 1, negative 0.3 around here. Then 2, 5.4 around here. And it is a curve. Therefore, we shall start from here. We join to this point, then to this point above, and we shall be able to get our curve. And therefore, you say this is our curve, e power x plus x minus 4. This is one graph, and this will be your first approximation, which you read as 0.9 if it is from the graph paper. And you will see that we have exhausted all the requirements for the graph. Therefore, if at all you have to draw two graphs along the same axis, we have to say we have a graph of y equal to e power x, and a graph, because you simply see that e power x plus x minus 4 is equal to 0. E power x should be equal to 4 minus x. You take x minus 4x on the right, therefore you shall have a graph of y equal to e power x, and a graph of y equal to 4 minus x. So we shall have two graphs. Therefore, you draw a table again, shall have x, then say like y1, which is e power x, then y2, which is 4 minus x. And this table will be made up of values. Can similarly say x from -1, then 0, then 1, then 2, then the values of y equal to 4 minus x, it will be 5, it will be 4, it will be 3, then at 2 it will be 2, at 3 it will be 1. And y equal to e power x, you get your calculator and you put shift of x, then when you put -1, it gives 0.367, but we have said you can have 0.4, 1 decimal place. When you put 0, it gives you 1. When you put 1, it gives 2.7. If you put 2, it gives 7.4. If you put 3, it gives 20.1. And you draw a graph again. You draw a graph whereby x-axis is labeled, y-axis is also labeled, and according to our values, you will see x we have begun from -1, so can have -1, then 0, then 1, 2, 3. As long as the scale is uniform on a graph paper, then shall have 0.5, 1, 1.5, 2, 2.5, 3, and so on. So let us begin with the line. We shall have -1, 5. This is 4, 5. 5 is here. Then 0, 4, 0, 4. Then 1, 3, 1, 3. So it will be a straight line which you must draw using a straight edge ruler, and you join the points. You get a line, a straight line sloping downwards, which will be y equal to 4 minus x. And y equal to e power x at 0, -0, 1, here. So it will be, then at 1, 2.7, it will be a line, a curve, sorry, of that nature. And therefore, this will be y equal to e power x. So the curve and the line meet, and where they meet, you draw a dotted line moving towards the x-axis, and where the line and the curve meet the x-axis, indicate that as x0, and your x0 will be read to 1 dp depending on the given question. So that is where you can use two graphs, and you realize that you have exhausted all the features of a good graph. So whenever you are drawing a graph, make sure that all the features that entails graphical method are clearly followed, and you'll be able to get the first approximation from the graph, which will later help you in finding the solutions of equations when it comes to other methods like using Newton-Raphson method, linear interpolation, and general iterative. I wish you a nice viewing. Now, similarly, when it comes to this graph work, ensure that you follow instructions. Instructions are very important, that you must follow them.